sine, cosine. Approximately. We are no longer referring it to a angle or a point in the coordinate space. So the problems that we did earlier, well, I drew a line and I ended up saying, well, the line is the first quadrant, second, third, fourth, etc. And last time I mentioned, well, even if you increase the radius, all you have to do is multiply by r. So x would become r times sine theta, y would be, x would become r times cosine theta, y would become r times sine theta, and then you are set for another radius, because no matter what circle you draw, the angle is the same. So the points will simply increase in magnitude. Right. But a unit circle is not a function. What?
Because they're overlap.
Do you mean overlap?
X's.
X's.
Not one to one. Because it's
Ah, not one to one. Until where?
I don't know. It's just they cross over the same line.
It keeps going this way. Vertical line test. So it goes in past vertical line test. As that then by itself is not a function. If you restrict the domain, it will be a function. Also, it's not one to one. For a given x value, we must have only one y value. Yes. So it will fail the horizontal line test. Also, so both are cool. So we are actually wanting to have a function. Okay. First, I am going to start with the window because I want you to see periodicity. So 2-part periodic, going to set the window from negative to pi. Positive side, positive 2 pi. Needing to worry about the scale. What is the maximum y value that sine will reach? 1 minimum, -1. Sure, I can set it at -2 to 2. You can see things better. Not a sine, because we didn't change that. There. Sine x. Good. Yes. Second mode. Well. Does it look like what I drew? Of course, mine's messy, not pretty, that's best. Agree? 0 to 2 pi, sine wave. Same on the other side, sine wave. Cosine is going to shift by 90 degrees. Sine is 2 pi periodic, is cosine 2 pi periodic. Yes, they are co-functions, so that's it. Your fancy calculators have color, so set it to a different color. Cosine x. Ready? Is it 4 pi over 2 shifted? Yes. Cosine. Sine is a nice little function. Cosine is the tangent is sort of trouble. Why? Asymptotes. Why do we have asymptotes? Well, you can have 1 over 0. I could have 1 over 0 because tangent sine over cosine. Look at the picture. Wherever cosine is 0, this bar tangent is going to cause trouble. Why does cosine become 0? Need to look at this or that. Pi over 2, cosine will be 0. Another point. 3 pi over 2. So on this side, it's pi over 2, 3 pi over 2. On the other side, negative pi over 2. Negative 3 pi over 2. And what do we know about tangents? Are they 2 pi periodic or are they pi periodic? Pi. Going to clear these out. We would like to see asymptotes. Pi over 2. Like to see an asymptote, same at 3 pi over 2. At 0, sine 0, 0, cosine 0 is 1, no problem. Pi over 2 is right here. I have an asymptote. Not a problem. So that is 2 pi right there. So thin graph. But 0 to pi over 2, 0 to pi over 2. So I have a pi period and it goes this way with asymptotes. Move over and I see pi to 3 pi over 2. I've got period, yes. Another pi period, you have another asymptote in both directions. Same on this side. It repeats. So it would repeat with the period of pi. Clearly it's periodic. And it has asymptotes, one going to a positive infinity, another towards negative infinity. So the other functions, tangent, cosecant, cotangent, all of those can be graphed in a similar manner. your calculator doesn't have cosecant, cotangent, what do you do? 1/, tangent of x. You get to use your calculator in this course. So what I'm thinking about is yes.